Yes. All right. Hopefully you guys can all see this, and we're going to go through some new types of genetics today. Our first type is called multiple allele. Okay, multiple alleles. Hopefully you guys can see that. I'll zoom in. All right, and you guys can still ask me questions, okay? All right, in multiple alleles, we've done single alleles where we've done type like big T, little t. We've even done dihybrids where we had big T, little r, little r. So this is something new when I say multiple alleles. All right, most of the time when we talk about multiple alleles, we're going to talk about blood and blood types. Anybody know a type of blood? Anybody says what type of blood you are? Anybody know something? Oh, positive. Good. Anybody else hear another kind? Ever heard of anybody talk about what type of blood you have? Okay. All right, there are 4 types of blood, and we're going to put the phenotypes first. All right, the phenotypes. There is type A, B, and O. All right, Hayden said O negative, which is right. The negative and positives are definitely a part. However, we're not going to learn those, okay? We'll talk about those in a little bit, but we don't really have to worry about it, especially when we're just looking at inheritance, okay? All right, the genotypes are very different, okay? For genotypes, if you have type A blood, ooh, I'm getting off the page here, you can have AA or AO. All right, if you have type B blood, you can be BB or BO. Angel, I don't see your pencil moving. Thank you. All right, or you can have type AB or you can have OO. Okay. Now, of course, in science, there's another way to write this because there's always more than one way to do something in science. And there's another way that makes it a little more difficult looking, but it's not really. You all are smart enough to figure this one out. All right, I'm going to write it in another way. It's meaning that you inherit blood, but then what kind of blood did you inherit? All right, you inherit this blood, type A and type A, or you inherit this type of blood, like this. Okay, thank you. So I use an I, capital A, or IA and a little I representing the O. All right, given that, let's think about what the next pattern could be. Anybody think about what the next pattern could be? Anybody have an idea? Anybody have an idea? Okay, let's try this. Capital IB, or capital IB and a little I. All right, maybe you thought that, you just didn't want to say it. All right, anybody predict what the next one's going to be? Come on. Okay, no, that's a good guess. Think about the pattern that we have here. It's going to have a capital I. capital I-A, capital I-B, or the last one is going to be little I, little I. Okay? So that's not really hard to be able to figure those out. Okay? All right, let's do some practice problems, okay? All right, so we're going to say a woman with type AO marries a man with type BO, blood. All right, a woman with type AO marries a man with type BO, blood. Let's do the Punnett square. AO, BO, AB, BO, AO, and OO. All right, so we have a 25% chance of inheriting type AB blood. We have a 25% chance of inheriting type B blood, a 25% chance of inheriting A blood, and a 25% chance of inheriting O blood. Wow, that's a lot of different blood types. This is an O for those children. Okay. Okay. All right, questions on this? All right, let's do one more. Okay, somebody just raise your hand and give me a type of blood. One of the four. Go ahead. O. All right. So let's cross an O type of blood with, what do we want to cross this O with? An AB? Let's cross this one with an AB. Okay. So we're going to do OO cross with AB. AO, AO, BO, and BO. Pretty interesting. Now, let's go back to talking about that universal donor. This one, the type O blood, is the universal donor. Okay? Meaning type O blood can give their blood to anybody and save them. This one is actually my family's bloodline. This is my dad, and this is my mom. So my dad and my mom, and I had a 50-50 chance. I could have been type A or type B. I'm actually type A. Type B is my sister. She's type B. Let's go back and look at our warm-up today on the screen. We'll pull that up. Ooh. There we go. All right, let's take a look at this on the screen. We said, I'm going to grab my face here and move me. All right, type O negative is what we consider a universal donor. It can give blood to every single person and save every single person can take O negative blood. However, O negative blood can only receive O negative blood. That's it. Everybody else, you cannot take their blood. Let's look at type AB blood. AB positive can accept blood from everybody. Everybody can save AB positive. But AB positive can only donate to AB positive. What do you guys think is your opinion of which is the best type of blood? Type AB positive or type O negative? What's your opinion? Would you rather save everybody or let everyone save you? Everyone save you. I've had that one a lot today. Okay. Anybody think type O negative would be the best blood? That's interesting. Okay. So my dad is O negative, meaning he can give blood to everybody. I am A negative, so I can give blood to A negative, A positive, AB negative, and AB positive. So I can save 4 people. All right. A lot of you think AB positive might be the best type of blood to have because everybody can save you. All right. That's very interesting. Okay. All right. So I am a O negative. My dad is O negative. My dad gives blood every 3 months to help out people. And my sister is type B. If I got into an accident and I needed blood, I could not take my mom's blood because she has a B. Now, really what this is meaning is each letter is attached to like an antigen or an antibody that your body cannot take in. So if I receive type B blood, my body would not be able to attach oxygen to it and I would die. I could give my mom type AO blood because my mom has A and O is recessive. Everybody can take O. So I could save my mom, but my mom could not save me. Okay. All right, questions here? Okay, can we do blood types from now on? Yes? Okay, we have one more to learn. All right, this one is called sex linked. All right. In science, we're talking about sex linked trait. Do you think we're talking about sexual versus asexual reproduction? What are we talking about? It's linked to what? What could these links or traits be linked to? Okay, this is linked to your gender. How in genetics do we describe gender for boys? What's a boy? What genetics do boys have? There's an X. What are boys? Okay, XY. So on your 23rd chromosomes, that pair, boys inherit an XY. If you remember on the karyotypes, we looked at pictures of chromosomes and we said boys had an XY. Anybody know what a girl is? Good. Girls are XX. Okay, so let's just do a fun one. Let's just do a boy and a girl. Grow up, get a good job, find the love of their life, get married, and decide to have kids. XX, XY, XX, XY. So it looks like they have a 50% chance of having a boy and a 50% chance of having a girl. XX. Okay? That's pretty normal. We can do that. All right, now these are traits that are linked to your gender. So we're going to write them kind of like we did the letter I's up above. Okay? All right, our first one is called hemophilia. Hemophilia is a blood disorder. PHIL, phile, means to love in Latin. Heme means blood. So these guys are called blood lovers. Ooh, that sounds weird. All right, what happens is normally your red blood cells, when they die, the cell membranes stay in your bloodstream. And they stay in your bloodstream so that when you get a cut, the cell pieces go up towards that boo-boo and make a scab. It stays in your bloodstream so that you can make a boo-boo. I got my finger pricked today. I did the biometric screening, so they took my blood today and gave me a prick to see my blood was good and healthy. Right? All my lab work came back pretty good. I'm pretty healthy. All right? But I have a boo-boo. So what's happening is those platelets, those pieces of cell membrane, are going to where my boo-boo was, and they're making a scab and stopping me from bleeding. Okay? Now, the good thing is I won't bleed to death. But if you're a hemophiliac, we got problems. Your kidneys clean out your cell membranes. So if you get a boo-boo, you just bleed. And you bleed and you bleed and you bleed, and then you die. In America in 2024, we have some kind of special glue that will glue the skin together, but you can't have surgery. You have to be very careful if you have, when you have a baby. There's all sorts of things. You can die very easily in childbirth. 100 years ago, no. 100 years ago, if you fell off of a slide and got a bruise, or if you needed to have surgery, or if you had a baby and you were a hemophiliac, you would die. Pretty crazy. All right, so let's try this. Hemophilia is recessive. So H is normal, and a hemophiliac is a little h. We're going to add it to gender because it's a sex-linked trait. So we're going to take a girl, and she's going to be this. Look how I wrote the little letters on the side. She is a heterozygous for hemophilia. This is also called a carrier. A carrier is one of your vocab words. It means that you carry the trait, but you don't have it. So this girl looks normal, but she is carrying the recessive trait. Let's say that she marries a normal boy. He's going to be X, little h, capital H, Y. He is a normal boy. I'm going to do the Punnett square. All right, the Punnett square. We're going to do the girl and then the boy. So you're going to do their gender, but you're also going to carry the hemophiliac trait. All right, this is a normal girl. This one is a normal girl, but she is a carrier. She does not have it, but she's carrying it. This is a normal boy, and this is a hemophiliac boy. He has it. So they have a 25% chance of having a child with hemophilia. If they have a boy, they have a 25% chance of having a kid with hemophilia. Okay? All right, there's another one that is a sex-linked color blindness. Color blindness is also sex-linked. Okay? So you're going to see color blindness and hemophilia are often used for sex-linked traits. Okay, can you figure these out? All right, on your big genetics packet, I want you guys to start with down here. You're going to start with the sex linked first. You guys should be able to do 7, 8, 9. This is on page 5 in your packet. Flip it over. You guys should be able to do 10, 11, 12, and then it goes into the multiple alleles, like blood. 13, 14, 15, 16, and 17. And then you're going to stop, and you do not have to do the polygenetics. All right, stopping here from polygenetics. All right, if you need help, you're going to come see me. And of course, if I'm not here, then you're going to look at the clipboard at the answers and make sure you have any questions written down so you can ask me next time. All right, for you guys, you get to ask questions. All right, anybody got questions right now? All right, for everybody, we're going to go to our groups, our lab groups, and we're going to finish working on the big genetics problem. Thank you.